Welcome to today's webinar. Today we investigate a roof structure for an additional load using the RFEM 6 add-on construction stages. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software, for instance, the German and English webinars. I will be the moderator today and I will answer your questions during the webinar. My colleague Ulrich Lex will be the presenter today. He's responsible for product engineering and customer support. He's, for example, the main responsible person for the development of the add-on masonry design, glass design, and so on. Okay, then I say some words how you can ask questions. At first, I switch off my camera that you can see the full screen. Just press that button with the question mark, enter your question in that field, press send, and I will receive your questions and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's at the moment all from my side. I hand over to Ulrich. Ulrich, it's your turn.
Thank you very much, Andreas, for your introduction. Hello to everyone, also from my side, to today's webinar. The topic of today's webinar will be the add-on construction stages in RFEM 6. For this, I prepared a roof structure, an existing roof structure, where we want to apply additional load, and where we have to take a look at the design checks if it is possible to apply this additional load or not. If not, then we have to find a solution that the design checks are okay also with this new load. Therefore, I want to take a look with you in the first step at the existing structure. After that, we want to take a look at the existing structure with the new load and think about solutions, what we can do if the design checks are not okay. In the third step, we want to design the new final state. And at the last step, we want to take a short look at the documentation. That's all for the theory, and we want to switch to RFEM 6. I already prepared the existing structure in RFEM for you. When we want to work with the add-on construction stage, then we have to check it on in the base data dialog of RFEM. Under the sheet add-ons, can you check the add-on construction stages analyze on? For our example, we had also to choose the steel design and timber design add-on. For the existing structure, it is a roof structure, an easy roof structure with main beams and secondary beams. The secondary beams has an cross section, a wood cross section with the dimensions 140 millimeters in the width and 320 millimeters high. The main beams has the same material with a section of 140 millimeter width and 520 millimeters in the high. The loading are prepared for the self-weight and a snow load. Any wind loads are not considered for our example. It's only to show and not to have too much load combinations. After that, we had to consider a additional load in load case 3. But at the first step, I want to take a look only on load case 1 and 2. That's why I have to deactivate the additional load from the actions, and my load combinations are created only for load case 1 and load case 2. There are 4 load combinations created. Load combination 1 and 2 for the ultimate limit state, and 3 and 4 the characteristic values for the service limit state. Okay, as the load itself, we had a surface load brought up with the load wizard, and the settings are in this way that the secondary beams are loaded. The secondary beams are connected with the main beams, and the main beams are supported on its start and end node. The same is for the snow load. It's generated with the load wizard snow, and the settings are the same, that the secondary beams are loaded and they give the load to the main beam, and the main beams are supported. Okay, the design properties for the structure are already done on the member side. I want not to take a closer look on these settings because today's webinar will be more on construction stages and not on the maybe timber or steel design. There are a lot of webinars available on our website for the special items where it is explained much more better. Okay, when we have these settings, then we can try to compute the existing structure, and we can take a look at the results according the current standard. I use the button calculate all to do the computation. When we take a look on the results, on the timber design results, and here pick our secondary beams, then we see that the design ratio is okay. For the ratio is for serviceability about 80% and for stability about 70%. It's okay, so we can try to assign this additional load, and maybe the checks are okay too. We will see later. So when we take a look on the main beam, we will see that the ultimate limit state is okay too, with about 80% of the design ratio. Only the serviceability is close to 1, is a little bit over 1. So I guess we cannot load it with the higher load. So we have to improve. We have to think about something what we can do that the additional load that is it is possible to load this structure with more load. Okay, when we take a look on our structure, then we have, as I already said, this secondary beams and this main beam. What could we do for improvement? Maybe we could try to create 2 additional beams on the right side and on the left side on this main beam and screw it together, and so to strengthen this beam that this additional load would be possible. If we want to do this, then we have to create some new things in RFEM. As a first part, we can try to create some line releases, because we need to have 3 beams on the same place, and this is possible with these line releases. The line releases are located under special objects in the navigator, and you can create a new line release. So we have as the first step to choose the lines. I will choose our 2 main beams. The beams on the side are not problematic because they get the half load, so they will not have problems with additional loads, I think. Continue with OK, then we have to define a line release type. I do not want to release something because we want to screw the new members with the main member. So I define no release, only in local X direction. I want to release it so that I get not much forces in local direction, normal forces So I define a small spring constant, only to get it not instable. Okay. So when we have done the settings, then we see the program will create automatically new objects and the one time new nodes and new lines. But I do not want to create new nodes. I want to use the existing nodes for the new lines. I only want to have a new line where I define afterwards a new member. So I can change it when I create the node as a definition node. That means that these definition nodes are an existing node and should be used for the new line. So I choose my existing nodes, and we see that only these two new lines are generated. Continue with OK. And we have to do it a second time with the same lines, and we choose the original line. The line release type is the same as before. We have to choose the nodes as definition nodes. OK. And continue with OK. So at the first view we see nothing, but when I select this line, then we see that there are now 3 lines on the same place. We can also see it in the navigator under lines. Here we have these 4 new created lines on the main members. So for this new lines, we can assign also, we can assign also members when we edit the lines and check on the member. Then we can choose any section. I want to use an UPE. You can choose it from the material database. So continue with OK. That was too fast. So we have to take a look at the section properties. Here we can remember to this value 22.7 because we want to set an eccentricity for this cross section. So we can here choose eccentricity and create a new eccentricity. It should be as a type relative and absolute, and the absolute value should be in Y direction. Here we can choose 70 millimeters for the half of the timber cross section from the main beam, plus 22.7 is 92.7 millimeters in Y direction. For the Z direction, we want to use this relative setting. Here we want to use the secondary member and continue with OK. Okay. When we activate the rendering and hide, then we see that our steel section, steel member is located under the secondary beam and on the right side of the main beam. So one thing we can do is to assign a hinge. Because of this eccentricity, it would be also the issue that if we not release the local X direction, that we get a normal force into the system, what we do not want to have. So I release also the local X direction with the small spring constant. OK. And continue with OK. So the same we can do for the left side. Also select the generated lines and edit these lines with a new member. Now I only edit this member number 4 and copy this member. Say I want to a rotation or mirror in about the Z-axis. Continue with OK and choose now the cross section 5. The same with the eccentricity. I edit eccentricity number 3, copy this, and only my Y direction is in the opposite direction. Continue with OK and choose my new generated one. OK. And as the last step, my hinges. This is the same as before. Okay. Now the new system, what we want to try to compute is ready, I would say. So can we take a look at the loading? As I said, I prepared this load case number 3 as an additional load. I check on to solve and I assign this load case in my action. That leads that new load combinations are created. There are also 4 load combinations, 2 for ULS and 2 for SLS. But in the new case, we have now load case 1, 3, and load case 2. Okay, as the load itself, it's a surface load again with the value 0.55 kilonewton per square meter. The load is generated with the load wizard. And the setting is the same as before, that only the secondary beams are loaded. So when we now would compute load case 1 or load case 2 with only the settings we have done now, then I think we would get wrong results, because the program would load this structure with all the load in one step. But my main beams does have a deflection, does have stresses from the self-weight before, and after that I screw these new steel beams with the main beam, and these main beams have to get additional deformations before these steel members can be acting. So, and this is now the time where we have to use the construction stages add-on. When we activate the construction stage add-on in the first step, then we get here in the navigator our construction stages. Then we can create a new construction stage. When we open the dialog, we have the first stage with start. Here we can assign all members and nodal supports in our case from the existing structure. You can do it when you click on, choose here members, add all members from the existing model. My secondary beams and my main beams. And here. Continue with OK. And the same for the nodal supports. We have to choose all supports. Okay. That means all things are now defined on this states are acting on the first stage. Then we can create a new stage. This new stage is following the first stage, and we can here now add our new steel members. And you see you cannot add a existing member in the second stage again, because it is acting in the first stage. Continue with OK. So we do not have new nodal supports, so we can continue with OK. You can take a look at your created stages when you choose here this first stage. You can see that only the existing structure is acting, and in the second stage, the new steel members are added. So then we have to, after that we have to take a closer look at the load cases and combinations. Here is the construction stages again, and here you can say on which stage which load is acting. So on the first stage only the self-weight is acting. On the first stage only the self-weight is acting. So, and at the second stage my additional load is acting and my snow load is acting. At the last step, I can say on the design situations that I want to create my load combinations on the step of the last stage. That means I can edit my combination wizard. I can consider an initial state, check on, and can say here I want to consider the stage 2. Continue with OK. And now when I take a look on my load combinations, I see that for both or for all load combinations, the initial state from stage 2 is considered. So now I can continue with OK and can take a look at the results after with this new structure, if now the design checks are okay. So when we now take a look at the secondary beams, so we see that our ultimate limit state is okay. It's a ratio of nearly 90%. So the secondary beams are okay with this new with this additional load too. Only the serviceability is close to 1 again. When we take a look at the details, if you double click, you can see the details of this design check. You can see that the deflection is 17.4 and the limit of deflection 16.7. So it's about 1 millimeter more than the limit. So for an existing structure, I would say this is okay, and I would not recommend any additional things for strengthening these members. So when we take a look on our main beams, then we see the ultimate limit state is okay. It's about 90%, the design ratio. Only the serviceability is not okay too. it's about 117%. And this is not okay. There we have to do some additional things. So what could we do now? First, we can take a look on the steel design for our steel members. There we have to assign the steel and run the steel design. So, and here we see we have a ratio of about 40%, about 40% and 70. So this steel cross section would be okay. The only problem is the main beam in the serviceability. So what could we do? We could increase the section, of course, but I'm not sure if it is really necessary, because this is an easy structure. Maybe we could try in the first step to lift up this main beam in the middle a little bit, and then screw the new steel beams together, and in this and then this try to compute this new step. I think this would be easy for an easy construction process. So we can now try to compute exactly these steps with the add-on. So if we want to do this, we can create a new support. A new support what is acting only in the Z direction, and assign it in the middle of our main beams. So as the next step, we had to create a new load case. A new load case 4. And here we had to create a new imposed nodal deformation in Z direction, maybe 18 millimeters, and assign it to my beams. So that means I want, in the first step, I want to compute my existing structure with my self-weight. So in the second step, I want to lift up my structure this 18 millimeters. And the third step, I want to screw together my new members. And in the last step, I want to design the whole structure. So this I have to create with these new stages. So in the first step, my existing structure should be acting. So in the second step, I do not want to add my new steel members. I only want to add these two new supports. Okay, then I have to create a new stage where I now want to add my new steel members. Okay, and as a last step, I want to deactivate my supports because they are not there in the end state. Here I can deactivate nodal supports too. Continue with OK. Then we have to take a look at the loads, and we have to improve here these loads. So on the first stage, the self-weight is acting. On the second stage, only my load case 4 is acting. On the third stage, only load case 4 is acting. And the fourth stage, my additional load is acting, my snow load is acting, and my load case 4 should be inactive. Only the deformations from stage 3 should be here in stage 4. And this is given when you have it as permanent, then these deflections are in the last stage 2. Okay, let us take a look at our stages. We want to start with our existing structure. Then we want to lift up the existing structure. We want to add our new members. And in the last step, we want to deactivate. You can see it here better. In the last step, we want to deactivate this supports and the lifting up. So when we take a look on the load combinations, then we have to change the design situation, the combination wizard. Here we have considered the initial state, but now we have not the state 2. We have to assign here the stage 4. When we take a look at the load combinations, then you see that for all stages, or for the load combinations are considered the stage 4. So now we are ready and we can try to run the calculation. We can use also calculate all. And hopefully the design checks are now okay. So okay, when we take a look on the secondary beams, then there is no change. It's okay because we did not anything on the secondary beams. When we take a look at the main beams now, then we see that the ultimate limit state is about 85%. It's okay, and the serviceability is about 98, 99%. This would be okay too. So this lifting up of the structure in the first state was good, and the design checks would be okay. So, but what have we take a look now to our steel section? The ratio of the steel section is now on 60, about 60%. Before it was about 40%. So this effect is for the steel section okay too, and the serviceability is here okay too. So this easy example shows how easy you can build this construction process in RFEM, and how easy you can create such things. And I think it's the best way to design it in more detail. As you maybe only increase this new cross section. So as a last step, I want to show you the documentation. For documentation, you can create a new printout report. If you do this, you will have on the first step the printout report manager. Here you can choose a lot of informations. You will get a lot of tables in the printout report, but you have to optimize this in your own way one time, that you really have this infos in the printout report, what you have to want or what you have to need. We can continue with okay. More interesting in my eyes is when you create also pictures, and you can do it when you print. Maybe here a graphic, you can directly print it to the printer, or you can print it to the printout report. When you choose this second option, then you can do a lot of settings. Maybe for the design ratio. So, and you can here save and show, since the printout report will automatically open. And for this way, you can see now here our picture. You have the table for the design ratio, and then the picture. What is better in my eyes as only the tables. So here you can print all things individual as you want and as you need for documentation. So that was all what I want to show you today. I want to say thank you for listening, and I want to give back to Andreas.
Thank you, Ulrich, for your presentation. Yeah, just an additional hint from my side, you can book our online courses. For example, the RFEM 6 course for beginners or the Eurocode 2 course for the concrete design with RFEM 6 or the Eurocode 3 course for the steel design. For more information, you can press that buttons at the bottom, or you can scan the QR code. The courses take between 2 and 3 hours. There are different chapters, and you can stop the course anytime and continue when you have time again. As I said, just click that buttons with the link or scan the QR codes for more information. Okay, that's also all from my side. I thank you for your attention. Thanks to Ulrich for your presentation. I wish all a nice rest of the day. Bye-bye.